Let's consider our first example. Suppose we're interested in the mean sales across all Dunkin' Donuts stores. We estimate the population parameter, right, this population mean, by taking a simple random sample of 155 stores and recording their sales for the month. For this group of 155, the mean sale is 176,400 and the standard deviation is 25,300. We want to use a confidence level of 95% and construct a confidence interval for the mean sales across all of our stores, not just the 155, but all of the stores. Let's jump to our Excel workbook for the day. Open your W10 D2 Excel workbook. You should see 3 worksheets. One says Sigma known. You can use this as a practice. We're not going to go over this together, but the solutions will be provided. We want to jump to Sigma not known, example 1. And we have our Dunkin' Donuts example set in that place. Okay? Now, as before, we have some information that we would collect from our sample. We could call that sample information. We have our critical value information, right, which is related to our confidence level. And then we have the margin of error we want to compute and 2 spots here for our confidence interval answer to go, right? Remember, a confidence interval is a lower estimate and an upper estimate, and we're confident that the true population mean falls in between them. All right, so as we did in the previous case, we're just going to work on the reading comprehension side of this, go through sentence by sentence, and think about what each sentence is trying to tell us. In the first case, suppose we're interested in the mean of the sales across all Dunkin' Donuts stores. We're referring to our actual population parameter we're trying to estimate. So we know that mu represents the mean of the sales across all Dunkin' Donuts stores. We estimate the population parameter by taking a simple random sample of 155 stores, and we record their sales for the month. So we have a little bit more information. We're talking about monthly sales. That's sort of the unit that we're working for this parameter. We also now know our sample size of 155. So n is going to be 155. For these 155 stores, there's our sample size again, the mean of the sales is 176,400. So we're talking about a sample mean. So this is going to be our x bar, x 176,400. And the standard deviation, this is still referring to our 155 stores. The standard deviation for that sample is 25,300. So inside of Excel, we can type this in. The last bit that we can fill in is our degrees of freedom. We might want to leave ourselves a note here. df is really just n minus 1, and that'll be the case for all the examples that we have to compute degrees of freedom by hand. So in our case, our degrees of freedom, which is going to help us choose the correct t-distribution to use, is 154. Our last sentence, using a confidence level of 95%, construct a confidence interval for the mean of the sales across all of our stores. So we're told that our confidence level is 0.95. Okay. So we're armed with all the necessary sample information. We've extracted that from the paragraph. Now what we can do is use our confidence level to find this special t critical value that we need to know in order to compute our margin of error. All right. Alpha is as it is before. It's 1 minus your confidence level. So in this case, it's the missing percent that we need to use to fill in the 2 tails. So this is 5%. Alpha over 2, remember we're dividing that missing percentage over the 2 tails. 1 minus alpha over 2, I'm going to do this in a separate cell. Normally I do this inside of our command. And we left ourselves a little note here. This is the area to the left of the critical value, t alpha over 2, that we want to find. So this is what we're going to plug directly into the command t.inverse. We're going to plug in the 1 minus alpha over 2, and this will give us the appropriate t critical value we want to use for this particular problem. And we have to use a t alpha over 2. Oops, forgot my degrees of freedom, right? Excel will prompt you probability, so this is the probability to the left. It'll prompt you for the degrees of freedom so we can reference our 154, or you could just type that in if you wanted to, and hit enter, we'll get our t critical value. Keep in mind we're using t critical because we're replacing our population standard deviation with a sample estimate. So the cost of that is using this slightly modified probability distribution. All right, so let's insert a comment to remind us of the formula for our new margin of error. So this is t alpha over 2 times our sample standard deviation divided by our square root of n. So as we build our command, we take our critical value, multiply by our sample standard deviation, and still divide out by the square root of our sample size, which is 155. This gives us the margin of error that we're going to add and subtract from our sample mean to get the confidence interval. So this gives us a margin of error of about 4,000, which means to create our lower bound, we're going to take our x bar, best guess estimate, 176,400, minus our margin of error. So on the lower end, we're expecting 172,385. On the upper end, in this case, we take our sample mean and we add the margin of error. All right. So we can be 95% confident that the population mean sales for all Dunkin' Donuts stores fall between 172,385, I'm just going to round, I guess, to the nearest dollar, and 180,414. Now the benefit of this is I didn't need to know what the population standard deviation in sales were among all the stores. I estimated that using a sample standard deviation for just the 155 stores we collected in this example. And then to adjust for the fact that we're using a sample standard deviation, we need to use a t critical value, a t alpha over 2. And that was adjusted for by the size of the sample that we worked with by providing this degrees of freedom information. So hopefully you're noticing a lot of parallels between the confidence interval we did in the previous class and this new modified confidence interval. They're basically the same, except we don't use sigma anymore. We use our sample standard deviation. And we don't use a z critical value. We now use a t critical value. But otherwise, it's the exact same process, as we can see from here. I've highlighted everything that's changed in red. We have a very similarly computed critical value. We have a very similarly computed margin of error, just with those minor modifications. Replace sigma with your sample standard deviation. Replace your z alpha over 2 with a t alpha over 2. And that's how we go through our process. All right, let's do our other example next.